Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous lecture we were discussing we had discussed these two data structure series and data frame from the Pandas package. So, we were specifically discussing the data frame object, data frame data structure. So, let us pick up from where we from the point we stopped in the previous lecture. So, we talked about data frame, and as we said that sometimes we will be dealing with larger data sets. So, therefore, we just want to have a look at first few observation, first few rows. So, therefore, head method can be really useful in that context. So, we can type a command like df.head and we will have those first 5 rows as an output. Now, the next thing is changing the column index using columns argument. So, this is we can use the data frame function that we have. So, just like the index argument that we have to change the row index. Similarly, we have the columns argument to actually change the columns index. So, columns index, as we discussed, is about the variable's name. So, we can always specify our own customized ordering for our variable names and all that. So, if you look at this code pd.data frame dict1. So, we are trying to create this data frame object from this dict1, and columns you can see year, metro and popcr. If you look at the output number 39, so their ordering is metro, year and popcr. Here the ordering has been changed. So, using columns argument, this is how we can actually do this. So, let me run this and you will see the output. Here metro and popcr, and the ordering has been changed, otherwise the we have used the same dict object. So, let us move forward. Now, let us talk about the as we said change we can also change the row index using the index argument. So, in the next example we have taken both, we are changing both columns index using columns argument in the data frame function, and also using index argument we are going to change the row index. So, if you look at the columns argument, we have specified year, metro, popcr, and we have added one more area. And so, what is going to happen is when we add this kind of another index value here in another label here. So, but this is not going to be present in dict1 key part. So, therefore, unmatching will happen, and one additional row is going to be created, index and row corresponding row, and with the index value is going to be in corresponding column, and with the index value area is going to be created. Similarly, if you look at the index argument, we have a list range 1 to 7. So, I think in the dict1 object, as you can see in the output 40, we have 6 rows. So, range 1 to 7 will give us 6 indices, those index values. So, we are fine with this. So, let me run this, and you can see in the output that we have because of the customization of the index, we have an additional column area. So, this additional column has been created as a result of index customization. And the values, because the values were not present in the dict1 object that we used to create the data frame object here. So, therefore, all NA and missing values have been indicated in this case. Now, let us have a look at the the columns index using the columns attribute. You can see here. Now, if you want to now how do we access different columns? If we just want to access one particular column, so how do we access that? So, accessing column using dict key like notation that just like we discussed there, the same kind of notation we can use in the data frame context as well. So, df2 and within brackets we can indicate the label within single quotes popcr. So, if our index is actually made of string values, that means labels. So, we can specify that within single quotes and then within the brackets operator, and we can access that particular column. So, if I run this line of code, you can see output 43, and you can see the column corresponding to popcr that has been produced in the output. Similarly, there is another mechanism to actually access these columns. So, we can access column using attribute like notation. So, just like we have been using other attribute like index and columns and others, similarly column names they can also be treated as an attribute. So, we want to access year column. So, we can type this code df2.year, as you can see next line, and you can see this year, all the data that was there in the year column that has been generated produced in the output. Similarly, we can retrieve the next another column popcr. So, using the attribute like notation df2.popcr. So, if I run this, we will have in the output 45, we will have this in the output. Now, sometimes while we are selecting columns, we would like to select a particular row indices. So, more on this we will be discussing further later on. However, few examples I have shown here as well. So, if you want to select few rows for a column, so we can specify like this df2, and within brackets we can specify the column label here. So, let us say popcr, and then another brackets, because you remember that they are based on arrays, and we said this is another way to access multidimensional arrays. So, in this fashion you can indicate you can use this colon operator here 1 to 4. So, we would be selecting in this output those rows are going to be selected and for that column. So, if I run this, so you can see for the popcr only the rows corresponding to indices 2, 3, 4 have been selected. So, you can see this in the output. Similarly, few more examples df2 popcr, and we have just mentioned the stopping point here. So, you can see here in the output. Similarly, we can use this -3 also. So, it will be counted from the end. So, you can see that kind of output has been displayed. Similarly, another example here we have not mentioned any start stop points, all the observations have been selected for that column. So, in this fashion we can access particular columns also, and also a few selected rows as well. Now, there is another mechanism that is Loc attribute. So, for a more precise access of rows and columns and values in data frame and series object, we can use these attribute. So, in this case df2 we can specify like df2.loc, and then we can specify the row. So, in this case 1. So, if I run this df2 loc 1. So, first row corresponding to index value 1 is has been displayed here. Similarly, another example df2.loc 4. So, you can see. So, this loc attribute or locate sort of locate attribute is can also be used to access this value. Now, let us move forward. Let us now talk about another aspect of these data structures. So, we will focus on data processing and transformation aspect of how these how processing and transformation can be performed using these series and data frame objects. So, we will take few examples. So, let us first start with the value assignment. So, let us pick area column. So, in this case you can see using the brackets and specifying the label area, we would be able to access the column, and on the right hand side we have just mentioned one values. So, that is going to be broadcasted across all rows, and all the rows and across all rows all the column values, all the area column values will have 6000 as the value. So, if I run this, and you can see in the output the area which earlier had NaN values, now you can see that for all the rows we have 6000 as the area value. Now, sometimes we might be required to populate values. We might be just manufacturing certain data set for certain demonstration, certain implementation. So, or for some other purposes also. So, sometimes these functions can be really useful, these mechanisms can be really useful. So let us pick again area column here, and you can see we can use this np.arange function, and let us say starting value 6000 and ending value 6600, and this step is 100. So in this fashion, instead of having just the earlier when we did perform the value assignment, the same value was assigned to all the rows. In this fashion also we can populate, we can use the arange function and populate equally distributed values in a certain range. So if I run this one and let us have a look at the output. So in the df2 you can see that along the area column in the output number 55 you can see first row we have 6000, then second row 6100, then 6200 and so on. So in this fashion we would be able to populate the values. Now we can also use series to populate values. So as we have discussed before that if there are any unmatched indices, so they are going to be treated as missing values. So let us take few examples. So let us say we have this series val, and we are going to create it using this pd.series function. We have 3 values and 3 indices. So you can see indices, if you look at the indices we are mentioned 2, 4, 6. So the remaining indices we are going to populate. So and then the next line of code you can have a look, df2 popcr. So we are picking up the popcr column here and we are assigning this val series object there. So for this particular column we are populating using the series object, and in the series object as you can see we can always specify the index. So let me run this, and if I look at the output you can see here that popcr, because we had specified just 3 indices, so 2, 4, 6, and we had assigned that the series object for this column. So the remaining values, there are missing values nan, and those corresponding to these 3 indices 2, 4, 6, they have the values from the series object. So you can see in this fashion we can populate the data frame object using a series object. Now we might also have sometimes we would like to add a certain column, and also we would like to populate some values also. So that can also be done. So you can see here in this example what we are doing, we are assigning values to a non-existing column, let us say northern. So in a sense we are saying out of the metros that we have which are in the northern part of India, so if this column is right now not existing, so this is going to be created. You can have a look at the code. So on the left hand side we have df2 northern, and on right hand side we have a conditional statement which will produce a boolean sequence. So df2 dot metro equal to daily. So as we know that from the metro column that daily is there, and daily happens to be in the northern part. So using this expression we'll have the boolean output there. For wherever daily is present, it will be for northern value for that would become true, which is the correct output, and for the other rows where we have Mumbai as metro, it would be false. So using this one line of code we would be creating a non-existing column, and we would also be able to populate the values also. So if I run this and have a look at the df2, and you can see that another column has been added at the end northern, and you can see for daily it is true for all the rows that are having daily as metro, it is true northern column, and for the Mumbai it is false. So in this fashion you can see how we were able to create a non-existing column and populate as well. Now sometimes we would like to remove a column. So for that like before we can use del keyword. So in this case we have just now created northern column here. So we can use del keyword and df2, and within brackets we can pass on the name of the column, label of the column. So that would delete this column. So if I run this and let us have a look at the columns index, you can see just 4 names are there here: metro, popcr, area, and the northern is actually deleted. Now let us take another example. In this one we are going to be using nested dict of dicts to create a data frame. So how this is going to work out? So what we will do, outer dict keys in this case we will use as column indices. You can have a look at the example also there, and the inner keys will use as a row indices. So if you look at the this nested this dict of dicts that we are talking about, we focus on the right hand part, we have daily as the key, and then in the value part this is another dict, and there we have year and population combination. So 2011 1.6, 2014 1.9. So you can see whatever data that we have been using till now while creating these data frame objects, it can be presented in this fashion also as a nested dict objects. So we can create this dict to object, and now we can use that to create a data frame. So let me run this, and we will have dict. Now we will pass on this dict to. So what will happen, inner dict keys they are going to be combined, and they are going to be shorted to form the index. So if I run this df3, I will look at the output. So now you can see that in the daily part of the dict2 object that you can see we had just 2 years 2011 and 14, and the Mumbai part we had 3 years 2011, 12 and 13. So of course the indices, the inner dict keys, those have become the row indices, and of course many of them were not matching. So all of them is union of indices has happened, and all those rows for those corresponding indices are present in the output, and we have these two columns daily and Mumbai, and wherever we did not have the value for whichever year, NaN has been introduced. So you can see wherever we had the matching data, so the automatic alignment of indices and value, that has been, you can see how that link is working out. So union of indices happens, and wherever the value is not present, NaN has been filled. So you can see in the output. So this is how we can create the another example of creating a data frame object. Now because as we have discussed, the data frame, they are like 2D arrays. So let us also focus on transposing a data frame. So essentially it is about swapping rows and columns. So sometimes this is also going to be useful. So if we just transpose df3.t, so you can see in the output, so you can see now the row indices, they have become column indices, and the column indices have become row indices. If you just compare the output number 63 and output number 64, you can see the indices have been reversed. So transpose T attribute has been can be really useful sometimes. So here the variables have changed, and name for row indices have also changed. We can also use a dict of series to create a data frame. So as we have done before also, but here we are working slightly differently. So in this you can see we have daily as the key, and in the value part we have a series object here. So you can see from the df3 data frame itself, we have selected a particular series daily column here, and we have selected certain rows also. And similarly for Mumbai part of the dict, in the series part, in the value part we have the series where we have picked up Mumbai column, and certain number of rows as well. So you can see in this fashion also we can structure our dict object. So you can see from the data frame that we have df3, from that itself we are able to create a dict2 object, and later on we can transform it. So all these examples are in a certain kind of transformation which might be useful. So if I run this and have a look at the dict2 object, so you can see, and we can use this to create a data frame. So next line is that, so using data frame function, and you can have a look at the output, that how for those rows. So wherever the matching happened, so for that we have the values, and wherever it did not, we still have with the NaN indicating the missing values. Let us move forward. Now let us talk about the name attributes in a data frame. So earlier we talked about in the series context. Now let us discuss this attribute in the data frame context. So df3, let us take this example. Now in this index, we can change the name of the index here using the name attribute. So df3 dot index dot name, we can keep it year because in the index we have those year values. So this is how we can change. So quite similar to what we did in the context of series. So df3 dot columns dot name. So here we have two indices. So for both of them we can change the name here. So df3 dot columns dot name. So and we can have a look at the output. Now in the output you can see that for the columns name we have metro there. So you can see in the very first row it's look like a header, then we have metro, then Delhi, Mumbai, and then for the row indices you have year mentioned there, and then row index obviously along that column. So in this fashion we can use the name attribute as well to define our data frame. Let us look at few more things about values attribute in a data frame. So when data frame columns have same d type, so if we look at the df3 values, so they will look like something like this. In this case all the values that were there in this data frame df3, they were of irrespective of the columns, they were of same data type, same d type. Now when these columns, they might be having sometimes one might be having string values, another might be having integer values or floating values. So different d types. So in that case, for example, we have this data frame df2. So if I run this, you can see every column is having a, so different d types have been used. So if we look at df2 dot values here, so you can see the array here and how those values are going to be. So how this values attribute is going to cover those, display those output. Now let us move forward. Now let us talk about few more aspect about index, few more points about index objects in series and data frame. So one thing is that these are immutable array like objects, because these are indices. So we are not supposed to modify them. So of course we customize them, so that flexibility is there, customization of indices. However, we are not supposed to modify. So they are immutable array like objects. So they also store certain metadata apart from the index values, the access label that we have. So to understand this, we'll have this, we'll take this example here. So in this we have sequence of labels A, B, C, which are going to be used while creating a series or data frame, and you would see there that they are going to be internally converted into index objects. So we have been talking about indexes, two row and column indexes for data frame, and just the index for the series. Now we are talking about the index objects, how they are created in the Python environment. So if I run this one, and if we look at the series 5 dot index, you can see index in the output number 76, and you can see in the d type it is saying object, right. So but however you can see in the output itself they are very similar to array like structure. Now in this certain operation we can perform with the index object. Let us talk about the series 5 index. So in this case we are storing ind1 series 5 dot index, and then we are using this subset colon operator, we are subsetting this. So ind1 and 1 column. So starting point we have mentioned, so A is gone and we are left with B, C. So in this fashion we can work with the index objects as well and select particular indices. Similarly, let us take another example, ind1 0 to 2. Now few more things that we want to discuss is one thing is immutability. So let us say ind1 and 1, so that is the index. So if I try to change it and try to make it assign it a different label, let us say D. So, let us see whether this will work or not. So, if I run this, an error has been generated here. You can see index does not support mutable operation. So, because the index is already there, index has been created and the associated associated number is there for accessing that index. So, that is not allowed, that. So, every label is associated with a number, that is not going to be allowed for modification. So, however, as we have discussed, we can always customize our index. So, let us take another example. In this case, we are going to create an index using index function. So, this is one function that can be actually used just to create index. So, earlier we have been customizing index using our series function and index argument, or attribute, index attribute, or columns attribute or columns argument. Now, in this case we are going to use this pd dot index function, and within that we are calling np dot arrange function, and we are going to create this index. So, let me run this, and you can see this is the index. So, you can see the index with 3 values 0, 1, 2. Now, while creating a series object, let us say series 6, we can use this index here. So, pd dot series, and we can run this, and we will have the series object with these values. Now, from this index we can find out series 6, we can do whether we can find out whether series 6 dot index is same as ind 2. So, if I run this, it will come out to be true. And another aspect about index object is that they display set like behavior. So, let us take one example. We will take this df3 data frame, and here let us look at the df3 dot columns here Delhi Mumbai. Now, you can see in the set data structure it was supposed to have unique values, and we can always find out whether a particular value is present in that set or not. So, in this case also index is not supposed to be modified. So, here also certain behavior is similar to set data structure. So, you can see we can check something like this, whether Mumbai is present in the columns index or not. So, within single quotes Mumbai and in keyword and df3 dot column. So, we can check the presence or absence of a certain label in the columns or row index. So, you can see similarly for the row index 2014, whether it is present in the df3 dot index or not. So, you can see set like behavior is there, and also we have discussed the immutability aspect as well. Now, one difference that index object have from the set data structure set object is that index they can have duplicate elements. So, if you look at the next line of code that we have, we are calling pd dot index function, and we have a sequence of values to create this index, and you can see beta is coming twice, beta then alpha then beta and sigma. So, this is not allowed in set because it is supposed to be a sequence of unique elements. But in the case of index, the behavior is quite similar to set, but duplicate elements are allowed. So, if I run this, we will create this ind3 index. You can see this index object, and the duplicate values are allowed. So, using this kind of index, we can create a series object. So, next example is about we are calling pd dot series function, then a list of values, and then we are using this ind3 index here. So, I can run this, and you can see that 2 rows are having the same index label beta and beta. So, try to access rows with the beta label. So, if I call series 7 and within brackets single quote beta. So, you can see all the rows which are having that beta label, they are going to be selected. So, they are going to be displayed. So, this is how the output is different, how the behavior of index object is different from the set object. Now, we will stop at this point, and in the next lecture we will start our discussion on some of the interaction mechanism with the data in a series or data frame. So, we will discuss those aspects. Thank you.